This is Euclid Book 3, proposition number 33, and this is a very long proof. That's right, Euclid Book 3, proposition number 33 is a very long proof. And what we're going to do is we're going to chop this up into multiple segments. I think it'll be 3 parts. It may be longer than that. Who knows? Let's just take it from the beginning here. We have a line, starts at point A, goes to point B, and you're going to have this line here, and you're going to have this acute angle here called C. Alright? And what Euclid's going to have you do eventually is he's going to have you draw an angle from point A to point E to point B. I'm going to show you this again. A to E to B. And this angle right here is going to be exactly the same size as this angle right here. Now, before we get into major anything, what we're going to do is we're going to draw an angle. And we already have one ray of that angle, which is AB. Okay, and we're going to draw the other ray from point A to point D. So therefore, angle BAD is going to be equal in size to angle C. Alright? Euclid then wants you to bisect line AB at point F, just like this. And then he wants you to draw a line from point F to point G. Alright? And when you do, this line here is going to be at right angles to AB. Now, Euclid goes on to say that you have line AD right here, but he wants you to extend that line AD like this. And when you do, Euclid wants you to draw a line from point A to point E, and when you do, this line AE is going to be at right angles to AD. Alright. Then Euclid wants you to draw a line from point B to point G. Now that we've done all of this, Euclid starts his proof. We know that the length of AF and AB, AF and FB, here's FB here, and here's FA here, these two lengths right here, are equal in size. How do we know this? Because when a line gets bisected, then the two parts will be equal to the one whole. Okay? So this will be equal to this because if you add the two together, you'll have the one whole. Anyway, Euclid then says that FG is equal to itself. Now, whenever you draw a line at right angles to another line, you're going to have 90-degree angles. That's just pretty much a fact. And because of that, this angle here, which is BFG, okay, and AFG, they're going to be equal in size. Now, because of all that, we ended up with something called side angle side. I am sure you remember by now what side angle side actually is. So, now that we have side angle side, we can also go on to say that the length of BG and the length of AG are exactly the same. Woohoo! And we can say all of this by Euclid Book 1, Proposition 4. Now what we're going to do is we're going to take our compass, put it at point G, have its outermost edge at point A, and we're going to draw a circle that's going to start at point A, come through point B, come all the way down here to point E. Now do this again. A to B to E. One very large circle. And we can then go on to say that line AD here, this is line AD here, it touches the circle ABE. Okay, we have a circle ABE, and AD touches that circle at point A. And we can say that by Euclid Book 3, proposition number 16. And then we can go on to say the angle DAB, well, where's DAB? Well, here's D, here's A, and here's B. This angle right here is equal to AEB. AE down here and back over to B. Okay? A to E to B. We can say these two angles here are equal in size because of what we just proved in Euclid Book 3, proposition number 32. Now, we already established earlier in the proof that angle DAB, this one right here, was equal to C. And since this one is equal to this one, then we can go on to say that angle AEB is equal to C. And that's what Euclid wanted you to prove in this first part of the proof. Now we're going to go through two other parts of the proof, and those will be coming soon, so stay tuned.